Okay, Concepts of Algebra 2. This is your 2-1 through 2-4 quiz review. 8 problems to do. Let's get started. Number 1. Determine whether each relation is a function. And we have 5 ordered pairs listed. Now what I'm going to show you to do is, to do this I would use a mapping diagram. I'm going to do a mapping. Okay? And to do a mapping, what I'm going to do, these ordered pairs, I'm going to put x's here and y's here. And I'm going to list my x's in order. So the x's are 3, 11, 121, 34, and 23. I'm going to put them in order from least to greatest. 3, 11, 23, 34, and 121. So I have the x's listed in order. And then the y's are negative 9, 21, 34, 1, and 45. Let's list those in order. Negative 9, 1, 21, 34, and 45. And now a mapping diagram is where you draw arrows from one x to the y that it corresponds with. So 3 goes directly to negative 9. 11 goes all the way to 21, right there. So not straight across, down. 121 goes with the 34. 34 goes with the 1. And the 23 goes with the 45. And that's a mapping diagram. And what you're looking for is you're trying to see whether each x, okay, the idea is each x goes to only one y. That's a function. If you have this situation, that is not a function. Well, if you look, each x goes to one y. So the answer is yes. Function. Determine whether each relation is a function. Function because each x is paired with only one y. And there you go. So that's the definition of a function. And this shows you what a mapping diagram is. Alright. Next, we have this problem. It says, write a function rule that models the cost per month of a long-distance phone call or a long-distance cell phone calling plan. Then evaluate the function for the given number of minutes. So in the things, you have a monthly service fee of $4.52. That is a flat fee. Then you have a rate of 12 cents per minute. Per means you need to have an x with it, or a variable. Okay? Something goes with that. So in this problem, I'm going to let C represent the cost. And I'm going to let M represent the number of minutes. So my function, cost equals, well, you have the flat rate of $4.52 plus the 12 cents per minute. Well, M is my number of minutes. That's 12M. And there's your cost function. So now it says, well, I used 250 minutes. So now we're going to evaluate this when, I'll use a different color, evaluate this when M equals 250. So what you do is you just plug it in for the M. So we got C equals 452 plus 0.12 times your M, which is 250. And if you use your calculator, that's fine. 452 plus 0.12 times 250, I get $34.52. 34.52. And that is the cost for 250 minutes on this long-distance cell phone calling plan. So remember, for these functions, there's always a flat fee and then a number that goes with the variable. Alright, 3 here. For each function, determine whether y varies directly with x. And this is that key phrase. If y varies directly with x, then you know y equals kx should work. Okay? So that's what we're going to do. And then it says, if so, find the constant of variation and write the function rule. So the idea here is, okay, y equals kx is the equation we use for direct variation. We need to figure out what this k value is. To solve for k here, we would divide by x, and your k value would be y over x. This is what we need to use to see if these numbers follow direct variation. Do we get the same k value for each pair? And I'm going to label them. 1, 2, 3. We have 3 pairs of numbers. So let's find the k value for all 3. So 1, k equals y 14 over x 2. That's 7. Good. That's 7. All right. Let's see. 2, k equals 21 over 3. That's 7. Hey, so far so good. The k's have stayed constant. All right, let's try 3 now. K equals 35 divided by 5. That's 7. Hey, there we go. This follows direct variation. Y does vary directly with x. K is 7, and your equation is y equals 7x. It is just y equals kx, replacing k with what it is, 7. So there we go. Here are the constant of variation and the function rule. Okay, next 4. Word problem here. It says, for a given speed, the distance traveled varies directly with time. There's this key phrase. Distance varies directly with time. We're still going to use y and x. I'm going to let y be the distance because it was listed first. X is then the time. So the equation y equals kx still works here, where y is distance and x is time. So it says Kate's school is 5 miles away from her home, and it takes her 10 minutes to reach the school. Well, that's sort of like giving you an ordered pair. 5 miles and 10 minutes. Remember, miles is the y, that's distance, minutes is the x. So this is really like the point 10, 5. So then the question is, if Josh lives 2 miles from the school and travels at the same speed, how long will it take him to reach the school? So now we're given this information. So we have a guy that lives 2 miles away, and the question is, how many minutes does it take him? We know the y, what is the x, right? We know the y is 2, but what is the x? Well, we need to do this in several steps, okay? So here, I'm going to slide down. First, we're going to use y equals kx, but we're going to plug in the information they give us, the 5 and the 10. 5 is y, so 5 equals k times 10. And again, that's just taking this information and plugging it in. And I'm going to solve for k by dividing by 10, and I get a half. There's my constant of variation. So my equation y equals 1/2 x is the function rule, or the direct variation equation. So now we know what y is. What is x when y is 2? 2 equals 1/2 x. To get this 1/2 away, we would divide by a half, but we don't divide by fractions. We multiply by the reciprocal of 2 over 1, which is just 2. And 2 times 2 is 4. That is the missing x value. How long will it take him? It'll take him 4 minutes to go 2 miles. So these type of problems have several steps. So just make sure you do all the steps, and you'll be fine. Okay. 5. We're going to graph this equation. And the way we're going to do this is by putting it in slope-intercept form. So we're going to use slope-intercept form. So to do that, I need to take negative 2x plus 5y equals negative 10, and I need to put it in slope-intercept form. Remember, slope-intercept form is y equals mx plus b. So I need to make this look like that equation. Well, here's the y. First thing I'll do is I'll add 2x to both sides. 5y equals 2x minus 10. Notice I put the x thing first because of my slope-intercept form. And then I'll divide by 5. And I'll do everything divided by 5. And we get y equals, keep this a fraction, 2/5 x. And then negative 10 divided by 5 is negative 2. There's my slope-intercept form. From here, I identify 2 things. The slope, m, 2/5. And the y-intercept, that is the point 0, b. b is that last number, negative 2. 0, negative 2. So when I graph this, okay, I'll put the y-intercept on first. 0, negative 2. right there. And then this slope means go up 2 and to the right 5. So from this point, the y-intercept, I'm going to go up 2, 1, 2, and to the right 5. 1, 2, 3, 4. And there's the line that is represented by this equation. So put in slope-intercept form, then identify your slope and y-intercept, plot the y-intercept, and count the slope. All right. 6 here. We're going to write this equation in point-slope form for the given pair of points. So they give you 2 points, 1, 9, and 6, 2. Now, point-slope form looks like this. Y minus y1 equals m times x minus x1. And what you want to replace is y1, m, and x1. You want those to be replaced. Well, look at what you're given. You're given 2 points, 2 sets of x and y's. So I can use one of them for x1, y1. But what about the m? Well, if they give you 2 points, find the slope. The slope, y2 minus y1 over x2 minus x1. Label your points. x1, y1, x2, y2. And plug them in the slope formula. 2 minus 9 over 6 minus 1. And this is negative 7 over 5, and that is your slope. If it simplifies, it simplifies. If not, leave it as a fraction. Simplified fraction. So now I can use either point and this slope and put it in point-slope form. So you have 2 choices. A, I'm going to use the point 1, 9 as my x1, y1. So your equation would be y minus 9 equals negative 7/5 x minus 1. There's one equation. Or B, you could use the point 6, 2. And you'd have y minus 2 equals negative 7/5 x minus 6. Because 6, 2 is your x1, y1. Okay? So either equation would work for your point-slope form. Okay, next, 2 more problems left. Number 7. We're going to find the intercepts and then graph the line. Okay? So here is our equation. I'll write it down. I'm going to leave it there. 2x plus 5y equals negative 10. To find the x-intercepts, we are looking for the x values when y is 0. So we take this equation and we cover up the y. And if you cover up the 5y, your equation says 2x equals negative 10. And this is the equation we solve for x to get x is negative 5. And there's your x-intercept, negative 5, 0. Now we do a similar thing for the y-intercept. If you want to find the y-intercept, you're looking for the y when x is 0. Plug in 0 for x, and the x term goes away, and you get positive 5y equals negative 10. Divide by 5, y equals negative 2. And that is your y-intercept. And you can graph the line by plotting those 2 points. Negative 5, 0. That is on the x-axis, left 5. 1, 2, 3, 4, 5. And then the y-intercept is on the y-axis, down 2. 1, 2. And there's your points. Connect them with a straight line as best you can. And there you go. And that's the graph of the line. Alright. Last one. Here we go. Write the equation of the line through each point. Use slope-intercept form. So, final answer is going to be in y equals mx plus b. So we have this point, negative 3, 1, and it says it's perpendicular to y equals negative 2/5 x minus 4. You need to know that that word perpendicular means the slopes, the m's, are negative reciprocals. So to put this in slope-intercept form, I need to start with point-slope form, which is y minus y1 equals m times x minus x1. And for this, I need a point and a slope. Well, I need a slope, and I need a point. Well, the point they give you, negative 3, 1. That's the point. Here's your x1, y1. But I need a slope. The slope comes from the line they give you. Here is the mx part. The slope of that line is negative 2/5. But you do not use this slope. If it said parallel, you would use this slope. But because it says perpendicular, that is the negative reciprocal of negative 2/5. The negative reciprocal would be positive, and the reciprocal is 5/2. So this slope, negative 2/5, became positive 5/2. And again, it's all because of this word, perpendicular. Parallel is same slopes, perpendicular, opposite reciprocals, negative reciprocals. So now we plug it in. Y minus 1 equals 5/2, x minus negative 3. To solve, we change our signs, that's plus plus. We distribute the 5/2. Y minus 1 equals 5/2 x plus, this is positive, positive, and you can give me a decimal, I believe you get 7.5. You could also keep it as a fraction, I don't care, but I think you'll do a decimal, 7.5. And then we'll add 1 to both sides. Y equals 5/2 x plus 8.5. And there's your equation through negative 3, 1, perpendicular to that line. Alright, so I hope you think this video helped. Wish you the best of luck on your quiz tomorrow. Thanks for watching.